Hello guys, I'm a teacher Masame. Let us proceed with our sessions. For first sessions, we have seen the velocity of man as recorded by moving observer inside the bus, who is the driver. Okay, and for this time, we must study the velocity of the bus as recorded by the walking man inside the bus. Okay, as usual, we have a two set of frame of reference. We have frame of reference for stationary observer, and we have frame of reference for a moving observer. As for frame of reference for stationary observer, he records the velocity of bus with respect to ground, with respect to him who is stationary at the ground. And this observer from the ground will record the velocity of a walking man, and as Vm sub g, this is velocity of man relative to ground. And the observer now, our observer who is moving inside the bus is a walking man. And this walking man is setting his axis coordinates as velocity of man with respect to the ground, and comma 0, that is vertical direction, is 0, there's no velocity in vertical directions. As this man is walking with respect to this moving bus, he will record the velocity of bus as it's moving away from him towards the right of his set of coordinates. As you can see, the bus is at high speed than the man, and is somehow outnumbered in velocity or displacement the velocity of man. Hence, we will have 3 projected vector here, and so this for this 3 projected vector is vector O, A, and we will have vector O B, and we will have vector O dash to C. Okay, now the first vector here is vector OB. That is, first vector is the one that the observer is projected or is set his frame of reference, and this first vector is OB, that is vector 1, and the second vector is the one that drawn from the head of the first vector. That is, this is vector O dash to C, which is second vector now, and the resultant vector is the one that drawn from the tail of the first vector to the head of the last vector, and here is the second vector, vector O dash C. Okay, then by applying the vector addition rule along the for one dimension relative motions, we add the first vector with the second vector, then is equal to the resultant vector. Here the first vector is velocity of man relative to the ground, plus the second vector is velocity of bus relative to man, which is equal to velocity of the bus relative to the ground. And this velocity of bus relative to man is always positive, as the man observing the motions towards the right of him, of his set of frame of reference or coordinate axis. Okay, then the will be velocity of bus relative to ground minus velocity of man relative to ground. Okay, which is equal to, for displacement, we take the final position, so we minus this initial position, we divide by time, that the observer or be spent to record the motions. And now the displacement, final displacement is equal to OA, and while the initial displacement is OB. For this, displacement is less because its velocity is less as recorded by a stationary observer, while this displacement for a bus, that is OB, is very, very big as recorded by this stationary observer. Hence, when we divide with time that is spent by this observer from a vector OB, that will be equal to the resultant value here is be equal always as a positive. Okay, thank you for watching. Please like, share, comment. Don't forget to subscribe for another cases.